So last time we saw this count and save. Now let's go to the next challenge. Longest common prefix. Write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. So flower and flow has F and flight has FL. Dog and race car and car has nothing. Okay. I think maybe there's a catch here. Yeah, maybe that must not be as easy as it seems at first sight. So my first thought is to just compare the first one from here, the first one from here, and the first one from here, and go to the second one and to the third one, and so on. And if it fails, we just return whatever we have until now. So the length of the strings can be 0. Okay, until 200. No, the amount of strings can be 0 to 200. The length can be from 0 to 200, and the strings consist only of ASCII characters. Okay, so let's think maybe about some edge cases before starting. So if it's empty, we probably just return empty. If there's any empty string at anywhere, we return empty. But this could be a general solved by the same logic as having any string and then returning whatever we already got as a prefix so far. Okay, I'll try starting with this idea first. There are some optimizations. Like, what if we start from the smallest string and then we compare with the first one, and then it must match some characters, and those characters must be the prefix for all the next ones. Then we need to go checking all the other ones. Would this be better than just doing this check one by one? We would detect the case where there is no prefix faster. But then again, we would need to remember that this is the one that we took to test, and thus string has a length, right? Yeah, I don't remember, because I usually, when I start those challenges, the first thing that I do is convert those strings to char array. So I'm just going to open IntelliJ here, just as just to remind myself. Let me keep Twitch open in case there's any message on the chat. So just to remind myself, because I completely forgot, but there must be obviously there is a length. Yeah, but this would not help in the worst case scenario. What's the worst case? All strings are the same, and it's a giant string. So the complexity would be O of n times if we say that the size of this array is n and the size of the strings are p, then it's O of n times p, right? Yep, because it's O of n for each string. Okay, so first let's do the simple solution, and then we try to optimize it. So the prefix starts as an empty array, and then we return the prefix. And here we traverse this array here. And then if all of them have the same character as the first one, then we append this character to this string. And yeah, appending will be O of n, so we need to use a string buffer. So new string buffer. And then again, I will need to check here. I think it's append. Yep. And here we need to get the first character, so I will create a variable character current, and then we need a second counter, which is the character that we are checking. So this is current character index starts at 0. Okay, and here if it's the first one, actually if the string that we are currently checking if the string we are currently checking dot length is greater, it's less than the current index plus 1, so if it's 0 we expect the string to have length 1, and so on. And if we find any string that the size is greater than this, then the prefix is already done because we can't go on, so we just return this prefix. Okay, and if not, that means that these string here do have a character at the index that we are looking for, and if we are at the first string, we want to know what character is this one that we are looking for, and for this we need to convert we will need to convert all those strings every time to a character array? No, right? So the first step is actually getting from this here. We need an array of characters. So something like this. Let's call it strings as char array, and this will be char array of you need to know the size. No, right. Can I do something like this? So this is dot length, and then I keep this as 0, because then I do the for loop, and then for each entry I add a new one, and I never remember where the square brackets goes. Oh. Correct. On the first try. Nice. So we do something similar to this, but then for each entry here we put this entry dot to char array. Okay, and now we can continue. This is already linear. This is of n times. Okay, it is linear. Okay, it's still linear time until this point. Okay, then we got here, and here we don't want this. We want actually this, and then at this point, and then length. It's not a function for arrays, and the logic is the same. So if it's 0, we want the first character. As the current character, and then we go, and then we continue until the last one, and after the last one we append at our prefix. So that means that here we keep going forever, like until, yeah, we will have some ending condition inside here, but here we need to go increasing the current char index until we have a case where we jump out here. Okay, while true. Okay, don't like this a lot, but yeah, but we have no way to know what's the size of the loop that we are doing here. The size of the loop is the size of the it's the size of the prefix actually. We would know if we went to with that idea of getting the smallest character string here, and then use this smallest string. Actually, I think I'm going to go with this approach because I think I see the optimal way of doing this. We get the smallest, we compare with the first one, and then we find the prefix between those two, and then we go to the next one, find the prefix and the next one until no, this will not work because the prefix needs to be common between all of the entries. Yeah, but then we know that we don't need to go further. We keep comparing with the next ones, but we already kinda know what's the prefix that could be. Not that it is for sure, but it could be. Okay, so that's what I'm going to do. So I'm going to have something like a prefix candidate, and this will be a char array. Candidate. do this? Yep. And then here I have the smallest string, and actually the prefix candidate nope, we will keep it like this, and the smallest string size, we don't need this, we have this, and then we can use the length here to check if it's smaller. So we do something like this. We start with size 0, and then here each time we copy, we ask if the current one dot length is greater than the candidate dot length, and if it is, we just use this as the candidate. So this way, at the end of this for loop here, we will have a candidate, and if the size of this candidate is already 0, then that means that all strings are 0, or the array is empty, and that means that we can just return empty. And here we already got this case covered, and we got this case covered, and we got this case covered already, because if here it is 0, the smallest possibility will already be 0. Yes, okay. But we could, here we could return already in this case. We don't need to keep going. If we find empty, it's already over. So we could have something like, if any of the strings are empty, we just return empty, just so we optimize that we don't need to traverse the whole thing. Good. And then at the end here, this will never be 0, because if it at any point this is 0, then it already returns, so we don't need to do this. Okay, and now that we have the smallest candidate, we can have the actual prefix, and the way it works is we are going to compare with all the strings inside here, in this case inside here, and then I don't think we need this string buffer anymore. What we can do is use the candidate here and have the index where this candidate finishes the prefix. So we have something like prefix candidate last index, and this starts not last index but size or length, real length. It starts as the actual length, and then instead of doing anything we just decrease this length. If all characters match, if some match we decrease it, if it goes to 0 we just jump out with empty, and if it gets to the end, that means that we need to return we need to create this string with all the characters from this here until this length. Yeah. Yeah, this way the worst case it's still the same, but the average case will be better because we pruned a lot of possible paths that we could have checked that we would need to process. Okay. So for each string, we compare them with the candidate. So candidates I from 0 until the length. Here I plus plus. And here we have char array, which is the current string that is this one at position I, and then if inside the current string at this point, if this is not equals to the candidate at this point, that means that the length of the prefix is equals to this index. So if it's 0, that means that there are no entries that are good. If 0 goes okay here, and then we get to 1 and 1 is different, that means the size is 1, and so on. And if we got here and it's different, we don't need to check anymore. We just break and go to the next string. If after all this, okay, we don't need to wait. Here, if this index here is 0, that means that there are no prefix, or these prefix candidate disagrees totally with the current entry. So that means it's not common. And I think that's it. Now we just need to convert this to a string. So for, again, we traverse from 0 until the length like this, and then we have string prefix, which is empty, and then for each entry we concatenate the entry here, and at the end we have a string with the result. Okay, so let's think about this and maybe think about some cases. So at first points we create a matrix of characters, so a list of character arrays, an array of character arrays. Okay, and we start with the candidate. And then for each one, if it's 0, we jump out. If the length is greater, and if it is okay, I think we already have an issue here. We want the smallest that there is there, so this is already wrong. Way to do this is to just first eliminate the case where there are no strings, and then we can put here at the first place the first entry from this array here. So let's do an exit clause here, where if this dot length is 0, we just return empty. So now we know that there is at least one entry here. And then what we do is we get this first entry, and then we convert this to char array. Okay. And now this should be, if it's smaller, then we get this one. Yes. And yeah, if it's 0, we jump out, and now we will have the smallest one here. Current one is smaller than the candidate. Okay, and then we remember the starting length, and then for each string here we get the current string as char array from here. Okay, and then we traverse the candidate length, and then for every one that does not match, we jump out, and if all matches, then that means that the candidate is okay. The size of the candidate is okay. We do this for all the strings, and at the end we just gather the result. I think that looks good. I always have compile issues, but some semicolon somewhere. Oh yes, array required, but int found. Oh. Okay. It's this. Okay, what now? Int cannot be dereference. This is not. This is already an int. Okay, let's submit. Oh, nice. Yeah, so the worst case is a string with the maximum size here, and this would be 200 times 200. So yeah, let's say that it's size n and the size of the strings is p, so n times p, which is n squared. So that's the time complexity here. About space complexity, I chose to not do this in place. So I have this copy, but if I didn't have to do this conversion here, yeah, then it would be O of 1 or O of the size of the prefix. Yeah. Okay. Cool. Maybe I need to check if I always need to convert to a char array. Maybe I'm doing this and it's not actually needed. Okay. But this is for next time. Okay, see ya. Bye.